Hi everyone, welcome back to Nuskrit. So let's solve today's daily LeetCode challenge, which is palindrome linked list. So let's try to read the problem statement first. So we are given the head of a linked list, return true if it's palindrome or false otherwise, right? So the question is very simple. Like the problem statement is very simple. We are simply given a linked list 1 2 2 1, and we need to just tell whether it's palindromic or not. Palindromic string is something like palindromic string or array or linked list is something like if you read it from left and right, it's same, right? Say for example, if you want to read this from left, it is 1 2 2 1, and now similarly if you want to read this from right, so it is again 1 2 2 1, right? So this is what we have to return. Okay, if it's palindromic, return true, otherwise return false. So now let's try to discuss what different approaches we have to solve this particular problem. So one simple solution to solve this problem can be like you can iterate the entire linked list, right? And you can maybe store all of these nodes in a list. Okay, so say for example, I will try to maintain a list and I can store 1, 2, then 3, then 4, then 3, and then 2, and then 1, right? And now once you have this list, now you can take two different pointers. One will be pointing to the 0th index and another will be pointing to the last index of this array. Now you can run a loop like until this pointer is not equal to this pointer, and you can compare both the values, they should be equal. So like 1 and 1 equal, so now make these two pointers like this, then 2 and 2 is equal, then make this pointer to the increment like to the next one, and then this pointer will be will be subtracted to 1, and then again the both of them are equal, and then again this is equal, right? So then you can actually return true. At any point in time, if left and right value is not equal, you can straight away return false, right? This is the first way to solve this problem. But again, like we are first of all taking big O and time over here and big O and space as well, right? But in the question, if you will read it, so it's a follow-up that write something like give the approach in which you are not really using any extra space, right? So how we can actually solve it without using any extra space, let's look at that as well. So this is my linked list, and now the approach that we are gonna follow is that what I'll do, I'll take this, I'll consider this as my first half of the linked list and this as my second half of the linked list, right? In case, let's say even number of nodes were there, let's say in case the linked list was something like this. So in case the linked list was something like this, then I would have assumed that this is my first half of the linked list and this is the second half of the linked list. And in case odd number of nodes are there, so I will assume this as my first half and this as my second half, right? Great. Now the idea here is that I need to somehow reach over this node, right? And to reach this node, once I have this particular node, now what I'll do, I'll simply try to reverse this particular linked list. Now let's say if I reverse this, let's say this list now has become 1, 2, 3 and 4, because after reversing these 4 nodes 4, 3, 2, 1, this will become something like this 1, 2, 3, 4, right? And this would be null. Now what I can do, I will have one pointer over here and I will have one pointer over here, right? And until until this list is not equal to null, right, you can actually start iterating over it, and then you can compare both of the nodes. So 1 is equal to 1, 2 is equal to 2, 3 is equal to 3, and then even if you will move to the next node, because 3 will still be pointing to 4, because you have simply reversed this, you have just changed these pointers, like 1 is pointing to 2, 2 is pointing to 3, 3 is pointing to 4, and 4 is pointing to null. You will do something like this, but this 3 is still pointing to this 4, right? This 3 will somehow still pointing to 4. So even let's say if you are at this node and you are at this node, so both of them are equal. Now you will move to the next node. So until like again you will move to this 4, and from here also you will move to 4, right? Let me just explain what I'm trying to say. So let's take two different pointers. One is slow and one is fast. Now let's say slow is moving one time and fast is moving 2 times. Now again, slow is moving 1 time, fast is moving 2 times. Now once again, slow is moving 1 time, fast is moving 2 times. At this point in time, you will not move forward because fast.next is actually null. So you cannot go really fast.next.next. You cannot go 2 times ahead, right? So you will stop at this point in time. And now what you will do, you will try to reverse this linked list, right? You will try to reverse this linked list. Okay, and now to reverse this linked list, it's very simple. If you haven't seen yesterday's LeetCode daily challenge, I would recommend that you go and watch, because that is in that particular video we learned actually how we can actually reverse the linked list, right? Now what will happen, so at this point in time, this is your slow, right? This is your slow and this is your fast. So let me point it over here, and now we need to reverse this particular linked list 4, 3, 2, 1. So what we did actually, so we took 3 pointers, the previous pointer, the current pointer and the next pointer, right? So initially what will happen, your next will start pointing to the next of the current, your current will start pointing to the previous. So current will start pointing to the previous means null, right? Just make sure that this is null, right? This is null, previous is initially null, so your current will start pointing to the previous. And now what will happen, your previous will actually become current and your current will become actually next, right? And now we need to repeat these steps. Okay, so which means now 4 is pointing to null, that means this link is broken. 4 is pointing to null, which means this link is now broken. And once again, let's do the same steps once again. Let's make sure that you point the next to the current, right? Then your current will start pointing to the previous. And now because previous is this 4, right? Previous is this 4. So your current will start pointing to the previous. And then what will happen? Your previous will actually become current and your current will actually become next. And once again, move next one pointer ahead, right? And now because the 3 is pointing to 4, so this link is broken now. Now next, once again, next is pointing to the current dot next. And now once again, your current will start pointing to the previous, which means you are breaking this pointer. And now your previous will start pointing to the current and your current will start pointing to the next, right? Great. Now once again, make next as pointing to the next of the current. And now make your current point to the previous, which means you are breaking this pointer. And now once again, your previous will start pointing to the current and current will start pointing to the next. And now at this moment, your current has become null. Now once your current has become null, right, you will stop because your list has been reversed. Now you can see that 1 is pointing to 2, 2 is pointing to 3 and 3 is pointing to 4 and 4 is pointing to null, right? But this 3 is still pointing to 4. Great. Now what will happen? Let's remove all of that extra stuff. Let's remove everything from here. We don't need even fast now. Now just try to listen to me carefully what now I'm gonna do, right? So I have this previous pointer which is pointing to this one, which was actually the last node of the original linked list. And now you have this head. You have this head which is the head of the original linked list. Now what you will do, you will say while maybe this previous is not equals to null, while this previous is not equals to null, right? While this previous is not equals to null, what you will do, you will say if previous dot val is not equals to head dot val. At any point in time, if this previous dot val is not equals to head dot val, you can straight away return false, right? You can straight away return false. Otherwise, make previous is equals to previous dot next, right? And head is equals to head dot next, right? This is what we have to do. So now what will happen? Let me remove this slow as well because this is not needed now. Now what will happen? Your head is 1, your previous is 1. Both of them are equal. So make your head point to the next and your previous will also point to this next. Now once again, 2 and 2 both are equal. This condition we need to look. If this is not equal at any point in time, we will return false. But both of them are equal. So make your head point to next and your previous will also point to next. Now once again, 3 and 3 both are equal. So head will be moved further and previous will also be moved to the next. Now once again, 4 and 4 are both are equal. So your head will move to the next, but the next of the 4 is not actually 3, but the head of the 4 is actually null. And eventually your previous will also be null, right? And at this time, your previous is actually null, so while loop will not run. So steps are very clear. First, we somehow need to reach this slow. And now we will pass this slow to the reverse function. That reverse function will actually reverse this entire node and it will give me the new head, which was this previous, right? We will return this previous from that particular reverse function. Now, once I have this previous, now this linked list will become like this and this list will also become like this. And now you can actually iterate this 1, 1, this 2 and 2, then 3 and 3, and then 4 and 4, right? Great. Now let's try to code this problem. And in this particular approach, we are really not taking an extra space. We are simply iterating over the list and doing the stuff, right? So let's try to code this. So what I'm saying over here is that let's first of all write a reverse function, right? So private list node reverse. And we will be receiving some head node. Like this head will be something else, right? But I'm writing a brand new function for this. So you should remember this, that we took 3 pointers yesterday, previous, current and next. Your previous will be equal to next initially is equals to null. And then your current is also, like current is basically pointing to head. While your current is not equals to null, you are doing 4 steps. First of all, make sure that you point to the next of the current. So next will become current dot next. Your current dot next will start pointing to the previous node, right? And after doing these steps, previous will become current and current will become next. Simple, very simple stuff. And now once these 4 steps are done, make sure you are returning previous from there because previous is now new head. right? So once this previous is done, now let's move further. Let's put some basic conditions. If head is equals to null, right, or head dot next is null, we can return true. We can return true. There is no need to put these conditions because our code can handle these situations as well. But yeah, let's put this stuff, right? Now we will take 2 pointers, list node slow and fast, right? And initially slow will be equal to fast equals to head. Okay, and now we make sure while fast is not equals to null, or and it's actually fast dot next is not equals to null. Make sure that you watch the previous linked list questions. There we have really discussed these things, right? Or you can watch my linked list playlist. So while fast is not equals to null or fast dot next is not equals to null, make sure that you run slow by next and make fast move forward by 2 times. So fast will become actually next dot next, right? Great. Now once this loop is ended, you will like your slow will be pointing to the 4th node as per our example, right? So what we need to do is we will say just give us a new head, right? So I will call this reverse function. I will pass this slow node, and from starting this slow, this will actually reverse the entire list from starting from slow, and this will give me the new head, which is the last node of the original linked list, which will be head 2, right? And now I can run a loop once again, like while head 2 is not equals to null, right? While head 2 is not equals to null, at any point in time, if head dot well is not equals to head 2 dot well, I will straight away return false from here. Otherwise, if everything is good, then make sure you move forward head dot next, and similarly you make your head 2 move forward by 1, and eventually you can return true. If anywhere you haven't written this false, then which means like the entire linked list is basically palindromic, and you can actually return true. And this is it. I think let's try to run this. I hope, like, hopefully this should run. And yes, the test cases are running. Let's try to submit this, and there we go. So this got submitted. So yeah, I think this was very simple approach. So this is it from my side for this video, and I'll see you in the next video. Till then, bye bye.